we're going to look at a couple more questions, probably a couple mixture questions, and then I'll give you that practice exam. Now, you have that already in your packet, but I made another copy with the key on it at the end. It shows you how I work through each and every step. That'll help get you ready for the exam next week. So we're going to look at some mixture questions next, because I know that these are ones, I'm trying to pick ones that I know students struggle with how to set up. Yep, and that's what we're looking at.
Can you do one that is the cross triangles where you're supposed to come out equal? The X.
Oh, vertical angles?
Yeah,
we can do one of those. Yeah, we'll just do a vertical angle right now, because I think there's a vertical angle one on the practice exam too, if I remember right. But it's something you need to remember anyways. These are there may not be a vertical angle on your practice exam, but I know there is at least one where you have to find the actual measure.
I can work it, but I can't get it to the same angle. It's equal.
Right. So I think what you're looking at, MJ, is something like that, isn't it?
Yeah.
Okay. Yep. We'll look at 71. I believe that's what we're looking at. So we're going to look at question 71, and this is on page 155. And there is one like this on your exam. I think it's a 180-degree angle instead of a vertical angle, but same type of concept. Now, vertical angles, they form an X. And they're going to equal each other. Right, they should be the same at the end. Okay, so we've got 10x plus 15 for that part. And we've got a 12x minus 3 down below. Now, what do we know about these? These are vertical angles, so they equal each other, don't they? Now, one thing that we have to remember on this problem, and there's one that's similar to it on your exam as well.
Don't we make them equal to each other?
Yeah, we're going to make them equal to each other, right? Because those are going to equal. Now, when we solve it and we find x, x is not going to be the answer. We have to find it, right? We have to plug it back in. So x is not going to be the stopping point. It's only half of it. So let's go ahead and work this out. We're going to find x, and then we're going to plug it back in, and these should be the same at the end. So let's go ahead and solve this. I'm going to move the 12x over. And that leaves me then with a minus 2x plus 15 equals a minus 3. Move that 15 over. And we've got a minus 2x equals now a minus 18. Divide by our negative 2. And we get a positive 9. Okay, but again, is this the answer? No, this is not the answer. Okay, to get the answer, what are we going to have to do? To get the answer, we're going to have to take this, we're going to have to plug it back in, right? And we're going to have to get both sides. So we're going to plug that back in, and we're going to see these should be the same at the end. So we've got 10 times 9 plus 15. So that's 90 plus 15. Adding those together, this side comes out to be 105, doesn't it? Okay, so the top one is 105. Now, if we did it correctly, what about the down below one, the one below it? It should also be 105, shouldn't it? So we've got 12 times 9. That's 108 minus 3. That also comes out to be the same, 105 degrees. So that's how you work out one of those. Right? We set them equal, and we solve them directly through. Okay. Now I do want to make sure that we know how to solve one of these as well. This is an easy one, but trust me, I've seen students miss this one a lot on the exams as well. One of these we had to find the better by. So page 164, we're going to look at question 22. And we've got a table. And we need to find the better buy. And this is on your exam. Well, not exactly, but very, very similar. Different numbers and different prices, but the same type of concept here. You've got a table, and we've got two types in this case of applesauce, and we want to find the better buy, or the best buy. Well, how do we find the best buy? We need to find the cost per, in this case, ounce. So we're going to look at the price over the size of the container. So let's look at the first one. Okay, the first one's $1.99, and it's 23 ounces. And $1.99, we're going to divide that by our 23, and we'll take this out to 3 places if we need to, and that comes out to be 0.08 if we round 7, and that's per ounce, so it's 8 cents an ounce. What about the 48 one? 48 is $3.49. So that's $3.49. We're going to divide that by our 48 ounces. And that gives you now 0.07 if we round 3. And that's per ounce. So which one's the better buy? Yep, 48 ounces is the better buy. I didn't want to work out the one on your practice exam because that's for you to look at. But if you look at your practice exam, okay, there is question 16 on that. And what is that one? Very, very similar, right? Do not miss this one. You'd be surprised at how many students make a mistake with this simple question here. And I don't want you to miss that one. Very, very important that you know how to do this question. It's easy. It's designed to be a simple question, not a complicated one. Now let's look at some mixture and some investment questions, because I know that when we look at applications, we struggle with those a lot as well. Okay, so let's look at some applications here that involve interest or mixture question or mixture problems or distances. Let's look at question. Let's see. How about we look at, let me find a real good one here to look at. A lot of these we've done already. Okay, let me find a good mixture one here. And let's see. There's several of them to choose from. How about we look at question number 26, and this is on page 178. So this is a classic mixture question. You will see the similar question in intermediate algebra. So this is on page 178, and we're going to look at question 26 here. And these are the ones that I know students really, really struggle with. How many gallons of a fruit drink that is 50% real juice must be mixed with a fruit drink that is 20% juice to get 12 gallons of a fruit drink that is 40% juice? So let's see what we've got here. This is a mixture question. Okay, we're mixing these juice containers together. They're different types of drinks. And we're going to read through it. We're going to take our time. We're going to identify what goes where. So we're going to start with our picture. It's a mixture question, so I like to use the containers. And 1, 2, and 3. And then we've got the amount, and then we've got the percentage rate. Okay, so let's read it through and stop at each part. How many gallons of a fruit drink that is 50% real juice? So the first thing I see is I've got 50% juice, and I have no idea how much is in there. So that's the X. So take little tiny parts at a time. So how many gallons of a fruit drink that is 50% juice? So that is this part, right? Okay. We're then going to mix that. So that's what we're going to add together. We're going to mix it with a fruit drink that is 20% real juice. We don't know how much, so we'll come back to that in a moment. We want to mix these together. And this is what we want at the end. At the end, we want to end up with 12 gallons, right, of a drink mix that is 40% juice. So that is going here. Now, what do we not know? Okay, we don't know what goes here. So how are we going to figure out what goes there? Well, that is always going to be the total minus X. If we don't know either one of them, we call the first one X, and the second one is the total minus X. So what is my total? When I'm done mixing these together, how many total gallons do I have? 12. So this right here is going to be 12 minus X, isn't it? Right, because that's where that came from. Is everyone okay with that? Now we need to remember how we solve and work out these mixture questions. Well, we need to work with the pure. And how do we find the pure? The pure is the amount times the percentage rate. And so we're going to do each box. So the first box. Now, percentages have to be converted to a decimal. So the first one is 50%. So that's 0.5. An unknown amount in it is X. The second one, 20%. So that's 0.2. How much is in there? 12 minus X. And the other side is your third box, and that's 12 times 0.4. Now we can solve it, right? Shouldn't have any trouble from here. Normally students, once they get to this point, can solve it. It's getting to this point and setting it up. That's where we struggle. So that is then 0.5x plus 12 times 0.2, so that's 2.4. Minus 0.2x, and that equals now 12 times 0.4, which is 4.8. Okay, we're going to combine, so those can be combined together first. So that gives you a 0.3x plus 2.4 equals that 4.8. We'll move that 2.4 over. So 0.3x equals now 2.4. Divide by the 0.3. And that leaves you with x equaling now 8. And on this question, we need to make sure that we answer the question. It says, how many gallons of a fruit drink that is 50% fruit juice? Does that match with what we want? Okay, X goes with what? The first one, and that was 50%. So what do we need? We need 8 gallons of that 50% fruit drink. And that's what we need, and that answers the question. Let's try one more. If we have time, we might do 2, but we'll do at least one more, and then I may let you out a little bit early. Let's look at a distance question. Okay, we need to make sure we know how the distance questions work. I know it's been a while since we looked at the distance questions, but for the distance questions, we've got to watch the direction. So, if they're going opposite directions, these add. If they're going north and south, they add. Okay? If they're heading towards each other like this, they add together. They subtract when they overlap. So this would be a subtraction question. The same thing with this one. This would be subtraction. And also they can equal. How do they equal? When you go to work and you come back home. Those are going to equal. So when we talk about the distance questions, those are the three outcomes. Add, subtract, or equal. Okay, it's one of these three. Normally it will be add, but not always. Because in many cases it's going to either be a subtraction one or an equals one. So let me find one that we haven't done. How about we look at, how about question 55? And this is on page 181. So page 181, question 55. Two cars start from towns that are 400 miles apart, and they travel towards each other, and they meet in 4 hours. Find the rate of each car if one travels 20 miles per hour faster than the other. So when I read this question, it says, two cars start from towns that are 400 miles apart. So what does that mean? That means that they're going to be looking like this, right? Town A and town B. And they're going to be heading towards each other. So what would this be? Addition, subtraction, or equals, do you think? This would be addition. So very important, the first thing we identify is what it is. In this case, it's going to be addition. And two cars start from towns that are 400 miles apart. So my total distance now is 400. So we read it, and now we're rereading it, but every time we encounter something, we write it down. So we've got our total distance now, that 400. Okay. What do we know about each of these cars? It says they meet after 4 hours. So each one of these has a rate of speed and a time. Well, if they meet in 4 hours, then each of these are going to have a time of 4. Okay, so the 4's go there because that's my time, my total time. Find the rate of speed of each car if one car travels 20 miles an hour faster than the other. So I'm going to call this one 1 and this one car 2. Do I know the speed of the first car? No, I don't. So that's going to be our unknown. So we're going to use X to represent that. Now, what about the second car? What does it say about the second car? It says the second car is what? 20 miles per hour faster, right? So one car is 20 miles per hour faster than the other. So the second car, its rate of speed is going to be X plus what? Plus 20. Now we can build our equation and we can solve this one. So let's go ahead now and build our equation. And we build our equation based off of the distance. And distance is rate times the time. And so for the first car, we've got rate times time, so that is a 4x. We're going to add that to the second car, and it's going to be 4 times x plus 20, and it needs to equal my total distance, which my total distance is the 400. Is everyone okay with how I set that one up? Now you should know what to do. Students generally don't struggle from here. It's everything before this. We distribute that 4 through. Okay, and that gives you now 4x plus 4x minus 80. That equals 400. We're going to combine them together. And that gives you 8x plus 80 equals 400. We're going to move that 80 over. And now we've got 8x equals 320. We'll divide by our 8. And now we've got it as x equaling now what? Yep, x equaling now 320. Divide that by my 8. X equals 40. I need the speeds of both cars. So one car is 40 miles an hour. What about the second car? It's 20 more, so it's 60 miles per hour. And I don't think we're going to cover any more today, so I'll let you out a few minutes early. I'm going to go ahead now and pass out the sign-in sheet. And I've got your practice exam. It's in that packet also. It's the same practice exam. So we've got 2 copies of it, so if you want to work it out again. And this one has the answer key. So this one has it. I actually worked it all the way through, so you can see how I did each and every step. You're welcome. But yeah, if you look at this, it's the same one that's in that packet. Okay, but at the end, you can see how I did each step, each question step by step. So I worked them all out step by step. This way you can see how they're done. And it's a combination of all the questions that we've covered. So different types, but we've seen all the different types. Next week we'll come in, we'll take our exam. I may cut it down to 20 questions. I'll probably give you some options too. So I'll probably cut it down to maybe 23 questions, and you'll be able to skip 3 of them. Or I may just do 22, and you'll be able to skip 2. But you'll be able to skip a couple of questions. And also remember, you can have a page of notes, front and back, or note cards.